In this video we'll set up the cameras for 3D digital image correlation. We'll start by determining the field of view required, which in this case is approximately the specimen size. As we see here, this is about 100 by 200 mm. Next we'll open up the DIC notebook, open up the template and save as a new file, name it by date first, then whatever the project is that you're working on. Choose the lens size first up, preferences for a longer focal length where possible. This will mean the cameras will be set up further from the specimen, so shorter focal lengths will be required if you're constrained for space. Don't use the 4.8s unless you absolutely have to. Set the aperture to 8 as a good default value. For base to specimen distance, take a guess. I've guessed 1000 mils here. This guess will give you a prediction for the field of view, so tweak it until your field of view is a bit larger than your area of interest. A focal range is also calculated from the aperture, and this is vital information if your specimen has some depth to it. An ideal stereo angle is labelled on the lens boxes, and so for my chosen 35mm lens, I'm trying to achieve a 15° stereo angle. Guess and tweak a stereo distance to approximately achieve this angle. And now we know our distances, we can start to set up our cameras. The cameras will mount onto one of these horizontal bars. Choose the smallest one that will satisfy your stereo distance. As my stereo distance is 270mm, this one will work nicely. Operating the tripod is pretty straightforward. Just know that the knobs twist to lock or unlock. The legs can spread out for stability. And that the legs extend from the base by twisting the collars at the bottom. The horizontal bar inserts into the head like shown here. Tighten it into position when the bar is central. Cameras are installed in much the same way. Note that all tools should be found in the drawers of the computer desk. Position the cameras at their set distance and equidistant from the centre. As my stereo distance is 270mm, I'm setting this to 135mm. Note that I'm measuring from the centre lever to the camera's mounting post. A quick check and we're good to go. Next, we'll install the lenses onto the cameras. Unscrew the protective caps and carefully screw the lens in. Never leave the camera without the protective cap or a lens for any length of time, as we don't want any dust to get onto the camera's sensor. Be very, very careful here. Do not drop the lens. Screw it down nice and tight. Repeat for the second camera. Store all the caps in the lens box and put the lens box back in its case. We can now position the tripod so they're at the correct base to specimen distance. Close enough is good enough here. Finish aiming up your tripod. And plug in the cameras. These ones shown are the USB cameras, which must be screwed in. However, there is also firewire cameras with longer leads available too. Strain and relieve the cables using the attached Velcro strap. This helps prevent cable damage and also helps prevent accidental camera nudges. Plug the other end in and don't forget to strain and relieve this side too. At this point you should see some little green lights on both cameras. Start the DIC Snap software. You'll initially get a couple of USB 2 warnings, don't stress about these. Hit the browse button to make some directories for yourself. We want to be in the VIC 3D data folder. Make a new folder here and name it after yourself and or your project. It's at this point I realised that I made an error in my video capture. I'm not actually getting the whole screen, so apologies for that. Hopefully it doesn't get in the way. I've named my project VIC Snap Training, and I'm going to put a folder inside this for my specimen. And inside that folder, I'll have a Cal folder and an SPL folder. Note that I'm selecting the Cal folder as my project path to begin with. At this stage we want to be in calibration mode and on the images tab. We're currently seeing nothing on the cameras, but that's because it could be too dark, or there's not enough shutter time, or the lens caps are off, or the aperture is closed. So we want to adjust the monitor position so you can see it from the cameras. The focus is adjusted by unlocking this ring and twisting the body of the lens, while the aperture is adjusted by loosening this thumb screw and moving the ring. For setup purposes, we want a very open aperture, say 1.4 or lower. Make sure you lock it when you're done. I can tell that the lighting is the primary issue here, so let's set up some lights. Open up the tripod legs for the lights and lock them into place. The lights will attach into this mount here. Make sure everything's nice and tight. The lights will all daisy chain together using these 3-pin XLR cables. The final light in the series will have this termination plug plugged into it, so start from here and work backwards. DMX in goes to DMX out on the next light and so forth. The final DMX in will plug into this Arduino controller, which will hopefully get its own box one day. The power can also be daisy chained between lights. Start at the last light and work your way back in the most convenient manner. You might find that this is a good time to clean up your wires. No point spending all this time on setup only to trip over the wires at the last minute. Use the knobs to turn up the light and see how it all looks on screen. We're going to spend a little time now refining the lights, angling them correctly so they're toward the specimen, and adjusting the camera rotation so that the camera's looking in the right direction. Loosen the Allen key here to allow rotation and tighten it back up when you're happy. Looking at the focus, we can loosen off the lock collar and adjust. Note that it might be easier to use the crosshairs to look at the center of the image and zoom into that region for focusing. Certain lenses can defocus when you tighten up the collar, so keep an eye out for that and adjust as required. Now I'm going to reduce the aperture down to f1.8 again in order to obtain a good focal range. Notice that I'm maintaining a relatively fast shutter speed of 10 milliseconds. Ideally I'd like to keep it to 10 milliseconds where possible, as this eliminates light flicker, because AC lighting flickers at 100 Hz. But it's also fast enough that motion blur won't be a problem. The end result of this so far though is that we're still too dark. Time to add more lights. In this new setup I've now got 4 lights all daisy chained to one another. Again, start from the last light and work backwards until you get to the first one. Clicking on the brightness tool at the top here will help us visualise how well exposed our images will be. The little white areas with red dots are overexposed, while green and under are underexposed. Do your best with lighting and aperture to get as much of your areas of interest to be pink or blue as possible, with as few areas as possible which are either white or dark. Next to this is a focus tool, which again helps us visualise how good our focus is. We can see here that our right image is not as good as our left. Use this tool to help finish off the focusing process. You'll likely need to retweak the brightness of the lighting in response to the focus adjust. In this setup I've also re-aimed the lighting slightly and then did a final brightness adjustment. You'll notice that I'm setting things up too bright here. This is fine though, as I'll be able to tweak the brightness down using the knobs. You should now have a very good camera setup, and all we need to do from here is calibration, which will be the subject of the next video.